June 2017, variant 1, paper 4. So it is number of the proton inside the nucleus. And then what is a nucleon number? Nucleon number, as we know, it's a sum of proton and neutron inside the nucleus. Why is hydrogen 1 hydrogen only atom to have identical proton and nucleon number? What is the reason why hydrogen is there? It's an only atom which is having identical proton and nucleon number, because it does not have any, so no neutron is there. Because nucleon number is a sum of neutron plus proton, and atomic number is equals to number of the proton. So for in case of hydrogen, neutron number is 0. If neutron number is 0, so nucleon number is same as the proton number. So the answer here, because there is no neutron, inside hydrogen nucleus. Complete the table to show the number of proton, neutron, and electron in an atom and ions given. Number of protons. Why hydrogen? The question was, Yusuf, why hydrogen, the proton number and nucleon numbers are same or identical? Because hydrogen, what is the nucleon number? Nucleon number is the sum of proton and neutron. Because hydrogen does not have any neutron, so this number is 0. That's why the nucleon number is same as the proton number for hydrogen. Complete the table. Use screen annotation to complete this table. You can use screen annotation to complete this table. So in case of fluorine, proton, because it's an atom, so proton and neutron electron number should be same. That's why if there are 9 electrons, there should be 9 protons. Because it's an atom, there's no charge. And neutron number, the difference, because as we know, atomic number is 9 here. So 19 minus 9, that's equal to 10. That's correct. In case of magnesium, proton number is 12. Neutron number, the difference 26 minus 12, that's 14. And because it's an atom again, so for that be an atom, the proton and electron number should be same. For phosphorus, what you can do, you can use the periodic table for this as well. Periodic table is given at the last. You'll find phosphorus is 15. So proton number is 15. Neutron number 31 minus 15, that's equal to 16. And it's a charge -3, so means there are 3 extra electrons. That's why it is 18 electrons. In case of strontium, it is 38. So proton number 38, the difference 87 minus 38. So 87 minus 38 is 50 or 50? 49. Yeah, so this will be 49. And because the charge is +2, so it lost 2 electrons. That's why it will have 36 electrons. Is it clear? Then write the formula of a compound formed when fluorine react with magnesium. What will be the formula of the compound? Use the screen annotation. What's the formula of a compound? Magnesium with fluorine. Yes. Because magnesium belongs to group 2, so it's 2 plus. Fluorine belongs to group 7 -1. If 2 valencies are not same, cross multiply. Magnesium fluoride. Then write a formula of a compound formed from strontium with phosphorus. Strontium phosphide. Yeah, that's correct, because what happened, the 2 valencies are not same. So if 2 valencies are not same, you will cross multiply. Strontium is 2 plus or +2, and phosphorus is 3 minus or -3. Cross multiply. So 3 will come with strontium and 2 will come with phosphorus. Now, some oxide and some elements are listed. Some oxide of some elements are listed. Answer the following question using only oxide from the list. Each oxide may be used once, more than once, and not at all. Which is the main source of acid rain? Acid rain, because sulfur dioxide burned, sulfur, like fossil fuel which contains sulfur, burn, form sulfur dioxide, and sulfur dioxide mixed with water vapors in the atmosphere, responsible for acid rain. Which would give the pH 14, which will make alkaline solution? It should be a metal oxide. That's correct, sodium oxide. Which is colored? Colored means it contains a transition element. So chromium 3 chloroxide, that's right. Which is a major impurity in iron ore? That's correct, silicon oxide. Amphoteric. Amphoteric means can react with both acid and alkali. Aluminium oxide is amphoteric. And the only neutral oxide, which one is a neutral oxide? Which one is a neutral oxide? So carbon monoxide is a neutral oxide. So this was related to your understanding of the topic. Only the acid rain part you will study in air and water. Others you already took. Amphoteric oxides and neutral oxide are different from each other. What is meant by term amphoteric oxide? What is the meaning of amphoteric oxide? So it can react with both acid and alkali. But neutral oxide does not react with acid or alkali. A substance that can react with both acid and alkali. That's true. Okay. Magnesium sulfate and lead sulfate are example of salts. So magnesium sulfate and lead sulfates are the example of salts. A student prepare magnesium sulfate. A student prepare magnesium sulfate starting with a magnesium carbonate, and student carry out experiment in 4 steps. What he did first, a student add an excess of magnesium carbonate to a small volume of dilute sulfuric acid until no more magnesium carbonate react. Then student filter to remove unreacted magnesium carbonate. Then he heat and concentrate the solution until it was saturated. The student allowed the hot filtrate to cool, and then he removed the crystal from it. How did student know when the reaction had finished in step 1? How he can identify?
Bubbles are formed.
No bubble, because it's a carbonate. If it was metal also, no bubbles form, because metal react with acid give hydrogen, carbonate react with acid gives carbon dioxide. So no more bubbles or no bubbles form. I'm writing in short just to explain the idea, not in detail. I'm writing the answer. Name the residue in step 2. What is left on the filter paper is called a residue when you filter it out. What will be the residue?
Magnesium sulfate.
No, magnesium carbonate. Why? Because what happened? You have a container. Magnesium sulfate is a solution. You have a container which is filled with sulfuric acid. So it is H2SO4. What you did in this, you add magnesium carbonate. So magnesium carbonate is added. So when you add magnesium carbonate, when the reaction occur, once the sulfuric acid will be used up, the solution will become magnesium sulfate. The solution will be magnesium sulfate, and you add excess or too much magnesium carbonate. So unreacted magnesium carbonate will be left. And when you filter off on the filter paper, you're left with magnesium carbonate. Not magnesium sulfate is a solution. So if they ask, name the filtrate in step 2, filtrate is magnesium sulfate, but residue is magnesium carbonate. Is it clear? The unreacted magnesium carbonate is a residue. Next, a saturated solution form is step 3. What is the definition of a saturated solution? Saturated.
That means no more solute can mix in solvent.
Yeah, no more solute can dissolve at that specific temperature, or maximum amount of solute is present in a solvent. So maximum amount of solute in solvent, or no more solute can dissolve why magnesium sulfate crystals form during step 4. In step 4,
Crystallization.
yeah, crystallization, but why because we cool down. So when you cool down the solution, when you cool down the mixture, the solubility decreases. Solubility means amount of solid dissolve in the water in the the water in the salt solution evaporated, but it's not like all of the water is removed. They concentrate the solution. They did not remove all. That's why again the filtration is done. So why the magnesium sulfate crystals are formed?
Because they're allowed to cool.
Yeah, they're allowed to cool, or solubility of a solution. Decrease as it cool down. That's why the solid will form. So we evaporated, but we did not remove all of the liquid. Like example, you have magnesium sulfate, which was having a greater volume. Initially, you heat this, you evaporate the water, but not all of the water. That's why you are doing filtration. Otherwise, filtration should not be done at the last. So it's a crystallization process. In a crystallization, we heat and concentrate the solution. So we remove some of the liquid, not all of the liquid. And we cool down. As we cool down, so what we observe, the solid, the crystals appear. Because less amount of solvent, so it cannot dissolve too much solute. That's why the crystals will appear. This is related to the moles stoichiometry topic. Lead 2 sulfate is insoluble salt. Insoluble salt can be formed by precipitation. When we mix two soluble salts, it will result in a formation of insoluble salt and soluble salt. We call that as precipitation. Describe how would you prepare pure and dry sample of lead sulfate starting from lead nitrate solution and sodium sulfate. So what you will do,
Displacement reaction.
precipitation reaction, double displacement or precipitation,
Ionic precipitation.
ionic precipitation or double displacement. So what we'll do, in one container, we will take lead nitrate, this is a formula for lead 2 nitrate, PbNO3 in a bracket 2. And the second container, we will take sodium sulfate. Sodium sulfate formula is Na2SO4. When you mix them, but before mixing them, just it's better you write the equation for this reaction, so you can identify if the ratio in the equation is 1:1, you should take equal volume. Like if I write the balance equation for this, if lead nitrate is reacting with sodium sulfate, so lead nitrate is Pb in a bracket NO3 2, and sodium sulfate is Na2SO4. This result in a formation of lead sulfate. So this will form PbSO4 plus sodium nitrate, NaNO3. And this will be 2. So it shows that the ratio of lead nitrate and sodium sulfate is 1:1 according to the equation. So if I took 10 cm cube of lead nitrate, I should take 10 cm cube of sodium sulfate for the reaction. So we'll take equal volume of lead nitrate, and for example, if it was not like example, if we for balancing, if you have to put 2 here, then you should take 20 cm cube of lead nitrate and 10 cm cube of sodium sulfate, because according to equation, you need twice moles or twice molecule, 2 times the molecule for lead nitrate as compared to sodium sulfate. But in this equation, because the ratio is 1:1, that's why you're taking equal volume. So you took 10 cm cube of lead nitrate, 10 cm cube of sodium sulfate, and you add them into another container or a test tube. So when you mix them into another container, what you will observe, you will observe a solid form. There will be sodium nitrate solution, but a solid is formed, which is lead sulfate. So crystals of a lead sulfate will appear. We call them as precipitate. when you mix two solutions and a substance is formed, you call precipitation. So I'll show you the steps also for this question. So what we did, we mix and stir the two solutions. We filter because we want to remove this precipitate, and we can wash this by residue. Why we wash this? Because already we know it's insoluble. So if any trace of or any solution is there on this solid will be removed, and then we can dry this solid by using a filter paper. Then write an ionic equation for this. So how we can write an ionic equation? All nitrates are soluble, and it is obvious we mix two solutions. So this will be aqueous, aqueous, solid, aqueous. We cancel out the common ion. First we write solid, liquid, and gas. So here lead sulfate is a solid, and we cancel out the common ions. So nitrate ion is aqueous, both sides cancel. Sodium ion is aqueous, cancel. So you're left with lead ion, which was +2 already mentioned in the question, and you're left with sulfate ion, which is -2. So lead plus sulfate gives lead sulfate. Question 4. Okay, we'll discuss next time. I have another class. The same paper we'll discuss tomorrow from question 4. This is Mayjune 17, paper 4, variant 1.